Thank you very much for inviting me here. I would like to bring the idea a little bit further away from the small world of quantum to the world of space. And I notice sometimes in the discussion that this is something which people do not necessarily combine. And this is not accurate, because there's a lot which is common and a lot of topics which are of common interest and a lot of potential synergies which I would like to work with you on through this talk. So first of all, no, I go one slide back. Who knows the European Space Agency? Do you have an impression of what the European Space Agency is? And so less than 20% in this room, and you are not such a big sample. So then I think it's worth to say a couple of words about the European Space Agency so that we have a common understanding what we're talking about. The European Space Agency is Europe's gateway to space. It is an international organization with 22 member states and some associate members, which is looking into fostering the collaboration among the space industry of these nations for exploration and use of space for exclusively peaceful purposes. We are located in different areas in Europe, and it's an organization with over 7 billion investment every year. That is the current status. What I think is important as a note, people often make a mix between European Union and European Space Agency. These are two different international organizations. The European Space Agency works and collaborates with the European Union in some projects, in some important projects, but they are two separate organizations. What nice way to think and remember about it is if you see the flags down there, there's a flag of Canada, which is obviously not a European Union country. So also the normal question about the UK, yes, the UK is part of ESA and is one of the main contributors. So what is the aim of ESA? What is, I think, a key characteristic of ESA, which is worth noting and makes it a little bit unique among other space agencies, like NASA or JAXA in Japan or Roscosmos and so on, is that ESA is involved and tries to address every possible area in space activities. And that means exploration, human exploration. It means space science, so cosmology-related planetary science. It means exploration of space in terms of Earth observation, in terms of navigation projects, the timing, which we will talk about later, but also communication satellites, so commercial communication satellites are also projects which are supported by ESA. So, of course, space is an area where world-class technology is needed, and ESA is trying to help the European industry achieve these technologies and ensure that there is adequate European sourcing for these technologies. Who should benefit from ESA? Who benefits? So probably there are some aspects which everybody knows, and it is like you're using navigation. In your current activities, you are using financial transactions which are based on time synchronization, which uses the Galileo satellites for synchronization of clocks. You're also using space-based telecommunication in several cases. But furthermore, what is important is the economy is benefiting. Space-related jobs in Europe are above, I think, 50 to 60,000 jobs. It is a significant contributor to the European economy, and the European space industry is a very significant one, which ESA is supposed to support. Going a little bit further, the activities are supporting our planet in terms of climate monitoring, Earth observation, which are significant in predicting and understanding climate. And another very significant aspect of ESA is our future in terms of inspiring the younger generations to think about these topics. Space is a particular topic which is very inspiring for people to think about science and technology and try to understand things. And this is a topic that I will go a little bit into in my next stages. So why are quantum technologies of strategic importance of ESA? So first of all, ESA has issued an agenda, 2025, a couple of years ago, where quantum technologies are identified as one of the key technologies that should be developed in Europe in collaboration with space, because they have a tremendous impact. Quantum technologies are part of ESA technology strategy, and this encompasses the whole variety of quantum technologies, so sensing, computing, and communication. And we have relevant programs and activities in every of this area, and we are seeking for collaboration with the industry in all this area. Because ESA is always working with the space industry and with the industry in general to develop the relevant capabilities. It is clear, and I think it was also clear in the sessions that we heard before, that Europe does have the potential. There are major initiatives from a lot of countries in Europe. And I think it was important that if somebody sums up the investment, the public investment in quantum technologies that is done in Europe, it is overreaching what US is doing and is almost matching China's. So if you add European Union plus UK, and if you add also Canada, then we beat the Chinese this time. But one important aspect is, and that is the part which seems that we are potentially lacking, is the private funding that should be matching that. And that is also one aspect of ESA, and I will come to that a bit later, how ESA works and how this co-funding mechanism should go. So why are we looking towards quantum technologies? Because we believe that they have the potential to deliver major disruptive changes in every area that we are currently active. So communications, navigation, computing, and sensing. I will go a little bit more into that now, but I think we need to try and understand that this is practically a lot of activities which space is supporting and offering for applications, but also for science aspects. And we should not neglect the second part. The fact that we have some applications which can have a business case does not mean that science is not important, and we should also be supporting this. So ESA has identified on a high level 9, I think I count correctly, 9 key quantum technologies for space, and we are trying to see, if we put it strategically, and this is something which is a cross-cutting initiative among the different directorates and units in ESA, to understand these technologies, what is the current status, what is the impact that they can have on the various space-related activities, and what are the steps that we need to take in order to bring them to the right technology readiness level, to probe them in space, and so on. The first part is quantum communication. This is an area where space is quite involved already, because we know that quantum key distribution is considered for space. Europe has relevant activities in this area. The Chinese have achieved to have quantum communication in 2017 from a satellite. There is an obvious reason why space is important, and the reason is simply the distance. In space, you can have quantum communication over a larger distance because the attenuation that you have on the signal is much less than you have in the atmosphere. So free space communications in space have a clear advantage, and that's why we're looking for that. However, this is not the only thing, because we are also looking at post-quantum cryptography to ensure that we have the security aspects in communications for space and in space. That means for communications that are involving space, we need to ensure that we have end-to-end these capabilities, but also for space communications. Going further into quantum computing, and I'll try to be brief on this, but I think it is important to understand that we are not just looking at sensors and devices that fly, but on the overall aspect. In quantum computing, we see a lot of potential in various areas, and what we are trying to do is to find out what are the correct algorithms, what are the algorithms that have a potential to bring change in space. There's a lot of computing involved in planning the missions, in understanding the orbits, in processing the data that are coming from the missions, and so on. And also topics like natural language processing or space robotics, because if we try to go beyond the moon, then it's not so easy at this stage to send humans. That means that we need to have the right capabilities to do this without humans on board. Coming now to sensors, which is the topic of this, this room today, I would like to bring into the sensors also the idea of atomic frequency standards, which means atomic clocks. Practically, atomic clocks is maybe the oldest quantum technology that is used. And if we consider now a current system for atomic clocks, we could consider the Galileo navigation system. So people often talk about GPS, but actually very much Galileo is used, which is the European system. Now, somebody should consider Galileo has 24 satellites, and if I'm not mistaken, every of the satellite carries 4 atomic clocks, 2 of each of the different technologies. Plus, these atomic clocks need to be synchronized with ground segment clocks to ensure that we have longer term accuracy. So it is clear that for an application which is currently used in many purposes, and when we're talking about navigation, it is not just about finding the next place when you drive with your car. Navigation capabilities are essential for many things. Positioning, navigation, and also timing, which is provided by the Galileo constellation, are essential for many activities, even though we don't necessarily notice. But it is clear that if this system fails, there are general disruptions. So we need to ensure that we have the right clocks, that we improve the clocks, and we have these capabilities going on. I talk about navigation, but practically if you take telecommunications, in telecommunications, synchronization is a huge issue, which again relies on atomic frequency standards and the clocks that we're using. Earth observation also needs to have navigation capabilities so that you know exactly where what is and so on. So it is an essential aspect. Coming now to the atomic frequency standards, I think it is important to go a couple of steps back, because actually we are using frequency to measure time, and with time we also measure distance. This is what Galileo is practically using. If you want to increase the precision of navigation systems which are using satellites, you practically increase the precision of the atomic clocks that you're using. And why should we confine navigation only on Earth? If we try now in the next stage to have activities on the moon and on other planets, we need to expand our navigation. And we need the navigation not only around the moon, so let's say for the rovers, but we need also the navigation to go to the moon and back, or to go to Mars, or to go beyond Mars. So we do have a need for navigation systems which are not necessarily conventional and which rely very much on precise timing. Going to the next part, if we do not think about the applications which are, let's say, using this science, it has a very strong potential if we're using capabilities of precision to go into measurements and measure and test fundamental physics. We need this for planetary research. We need it for geodesy and understand it. One example would be if we want to do, so we have general relativity and we have quantum mechanics. We have a standard model for the particles, and we have a standard model for cosmology. In order to check how these two combine and where are the conflicts, we need precise measurements, which need improved clocks. So what should ESA be doing in this direction? ESA should be, maybe that's not so nice visible in this, should help increase the technology readiness levels of the various equipment that need to be used, then prove it in space, and set it into use. And we are seeking to support companies that are, or to support industry, to develop all these activities so that we are certain that these can be sourced in the European countries. As a next stage, quantum sensing, and I take here 2 examples. And luckily, I will start with a cold atom interferometry, because I think if you were here in the Airbus session, the colleague from Airbus explained very nicely how it works, so I don't need to go into this. He did it much nicer than me. But what we can do is we need to improve our gravimetry measures. The picture of the geoid of the Earth, which is a picture there, is something which was developed from an ESA project with classical capabilities. If we want to improve that, and there is meaning in improving that for multiple reasons, we can use quantum sensors. The activities have already started, so cold atom interferometers are probed, and the first probe is to send it into flight, then try it out in ISS and so on, so that we deploy the system. So it's a lengthy process, which we need to achieve. But this is something which we can use for monitoring climate change. There is an activity in ESA which is about quantum capabilities used for climate. It's called Quantum for Climate. But I think it is also very important because through this way we understand and monitor our environment, and we can also use the same technology and capabilities to measure and understand other planets. And here I come to the idea about quantum-enhanced sensing techniques, where the current mission that is going to orbit around the Jupiter moons. So the launch was done a few months ago, and it is now underway. So you understand that this is something which takes a bit longer to reach Jupiter and go around the moons. It is already carrying a magnetometer which has quantum enhancing. It allows us to have something which does not necessarily need calibration. So the combination of magnetometers is something that can be used in order to measure the magnetic field in the Jupiter moons. So how is the way to work with ESA? ESA has a set of programs and tools. Programs are financing capabilities, and there are about technology development, general topics, current technologies, advanced telecommunication, and so on, and has also some tools like the ESA Star, which is a tool for tendering, where ESA is announcing the various tenders that are running on specific topics, and the OSIP, which is an ideation platform, newly added into ESA, where we are looking for ideas and topics in these areas, looking for the right collaboration and the right approach to go forward. The idea is that ESA is practically interested to fund from very early stage and has the right tools, depending on the different sets here, has the right tools to speak about early development, where the basic technology is evolving, up to a product level, or a system level, or a concrete service that will be offered. And practically there are 2 larger variants. One are ESA-initiated competitive tenders, where ESA is practically thinking that this is something that we should be having in Europe, but we do not see an activity from the industry, and that means we are funding this 100%. The idea behind that is that we are practically purchasing this capability from somebody. This is normally for early stage. It wouldn't be done for something which is close to product. But when we go close to product, we are considering industry-initiated projects. The funding depends on the characteristics of the project, the characteristics of the consortium members, and so on, where we're targeting higher TRLs and targeting something that goes to the market. Practically, ESA does not seek to keep the IPR on that, so the IPR is on the company that is working with us on this. But you are getting, or the company is getting, I assume that you are the company, or you are getting the funding, plus the expertise that is valuable for working in space, especially for companies who are not coming from the space environment. I think this is quite valuable. Especially you have some, let's say, more neutral approach to that, as opposed to working with a specific space-related company, if that makes any sense. But also with a specific space company would make sense. For larger companies, ESA could also have this co-fund a portfolio of projects where ESA is collaborating in acquiring or establishing the right purchases the right technology in steps from various companies in the industries. So practically, with this very nice sketch that was developed by a colleague of mine using AI, generative AI for pictures, the goal here is that ESA seeks to be the lab that allows companies to develop capabilities for space, and space is extremely broad in what we are considering, and we are seeking for possibilities, and we are seeking to help companies to achieve this in the member states. Thank you.